So basically I want to do something I can teach very easily because I know off by heart. So this is progressive waves, wave speed, phase difference, longitudinal and transverse. So basically, waves transfer energy from one place to another without transferring matter. That means that basically the particles in the wave don't actually move, they just move energy. There are two types of wave, transverse and longitudinal. Longitudinal waves are the waves that look like this. So they are a series of compressions and refractions. Whereas transverse waves are waves that look like a wave from the sea. So they move perpendicular to the direction of propagation. So the direction is travelling. Simple. Questions. Wave transfers something from one place to another. Energy. Simple. So, frequency and period. All waves have frequency and period of oscillations. Frequency is the number of oscillations per second. Frequency equals number of oscillations divided by time. Frequency equals 1 divided by period, and it's measured in hertz. And a period is one full wavelength, basically. Period is a wavelength, apparently. A wave with a frequency of 3 kHz was found oscillating 24,000 times. Over what time period? 4. That is because there's 6,000 divided by 24,000, which is 4. So parts of the wave frequency equation: number of oscillations, time taken, and also the frequency. Frequency is the number of time taken times number of oscillations. What is defined as the greatest distance a point from a wave moves from its rest position? That's the amplitude. So the something of a wave is the greatest point, the amplitude. Simple. How will a cork behave in water when waves are present? It will move up and down. Yeah, it will move up and down. It just won't move like any other way. So what colour corresponds to the wave frequency? Obviously, the big F. Obviously. The wavelength is the distance between two adjacent wavefronts. Simples. What do waves transfer? They transfer energy. Because particles don't move, well, they vibrate and move the energy. So, next is wave speed and phase difference. So wave speed equals the wavelength times frequency. I'm pretty sure. Yeah. Wave speed equals frequency times wavelength. So we can calculate wave speed by multiplying the frequency by its wavelength. Simple. A wave has a frequency of 4 Hz and a wavelength of 8 meters. How fast is it travelling? So 4 Hz, 8 meters. So wave speed equals frequency, which is this, times wavelength, that. So m/6 32 meters a second. Simples. So elements: wave speed, frequency, and it also is wavelength. Simple. So phase and phase difference. The phase of a wave is an important concept in physics. It can be expressed in fractions or cycles as an angle. Okay, I can explain this probably better than they can. So basically, a wave looks like this. Forget the red one. The wave looks like this. So the phase is how far through the wave it is. So say this is 0. One full wave, so this full thing, will be 360 degrees, here to here. When radians, or radians, or however you want to pronounce it, that's 2 pi. So, say they wanted the phase difference between this point and this point, that'd be pi, or 180. Simple. And obviously, that is how you do it, radians, etc. How many radians are in 180 degree pi? The formula for radians is the angle divided by 180 over pi. Phase difference is a measure of the something where the two something are in their cycle, waves. A measure of the distance, well, it is distance actually. It's really angle. Well, I don't know how you say it. How describes. Phase is a measure of the something in which the two waves are in their cycle. Is a measure of the something in where two waves are in their cycle. Phase difference is a measure of what? The difference were in two waves, and that took a while. Because I was only talking about one wave, but there's two. So one full cycle of a wave is called the peak to peak value. Well, no, it isn't. But I feel like it's not one full cycle of a wave isn't called the peak to peak value. It's called its wavelength. Yeah, but I thought it was too long to actually be like chosen in a way. But apparently it is, so that's fine. Oh, what am I looking for? This is going to be here. That's close. That's close. Theoretically, I could have been right, and they could have just put it in the wrong place. Longitude and transverse waves. So, a transverse wave causes the particles in the medium, the substance that the wave travels through, to vibrate at right angles to the direction of the wave's motion. So, say the wave's going that way, the particles would go up and down and up and down at 90 degrees. So what are some examples of transverse waves? Mexican waves and water waves, but they go like this. A transverse wave causes a something of the medium to vibrate at right angles to the direction of the wave something. The transverse wave causes the particles? That's not spelled particles. Particle of a medium to vibrate at right angle to the direction of the wave's motion, or direction of propagation as they would call it. A longitudinal wave describes the medium's particles to vibrate in the something direction, same direction. So example of longitudinal waves, P waves, so those are like earthquake waves like things, compressing, expressing a spring, and sound waves. So, longitudinal waves, here are some examples: springs, P waves, and sound waves. Simple. Transverse waves, obviously we've been through this, speed of light, 3.10 to the 8. There isn't really much there that you really need to know. All electromagnetic waves are visible and travel at the same speed. Well, they're not visible. No, they're not. They're transverse. They're all transverse and travel at the same speed, yes. Yes, they do. What are some examples of longitudinal waves? These are water waves and Mexican. Well, longitudinal, that is the up in the compression. That one. What kind of waves are EM waves? Transverse. There we go. In an electromagnetic waves, the electric and something fields oscillate something to the direction of energy of propagation. The electric and particle, nope, the electric and what fields oscillate at right angles, perpendicular. The electric and something fields, the electric and what other fields are there? What other fields are there? Electric and magnetic. Simple. And that is basically progressive waves done.